Hello dear students, welcome once again to our favorite That's It YouTube channel. I am Kasu sir discussing the concepts related to the organic chemistry through PYQs. In our last session, that is in the session 10th, we have discussed the questions on oxygenated compounds of the organic chemistry. You know that these chapters comprising alcohols, phenol, ether, aldehydes, ketones, carboxylic acids and its derivatives is very important as far as the IIT JEE advance is concerned. And moreover, the question that are asked are usually reaction based. So you need to remember the sequential reagents which are being used in these questions. So when I say sequential reagents, they might be oxidizing agents, and the important ones are the iodoform test, PCC in DCM, reducing agents such as lithium aluminum hydride, sodium borohydride, isn't it? Hydrogen in presence of palladium barium sulfate. Then you have the dehydrating agents such as alcoholic KOH and ANH2. So such type of reagents which are popular have to be thoroughly remembered, because most of the questions asked from these chapters are reaction based but not concept based. So today we are going to see some more questions from these chapters which were previously asked. You can see one of such question which was also asked in the previous IITs from the other chapters, like I discussed electrophilic aromatic substitution, where you can see similar question is also found. You can see this whole unit which is undergoing the electrophilic aromatic substitution, that is Friedel-Crafts acylation. You have to pick up the spot which is more viable to be attacked. You can see that this is sterically hindered because of the bulky group, this is sterically hindered because of the bulky group. So only one position which is viable is position P. So when I am carrying out the acylation, you know that what will happen, that this carbocation, the acylium ion, you call it as acylium ion rather, will attack at this position, giving rise to what? C double bond O, isn't it? CH2 CH2 COH. So this is your first substance, that is Q. Alright. Now in the next step you can see that you are reducing this by zinc amalgam and HCl. Zinc amalgam and HCl. So Clemmensen reduction, isn't it? So your C double bond will vanish. You know that, isn't it? So what do you get? I'm saving time, I'm not writing all the components here. You can see nothing is happening over this side, but this will become CH2. There are two CH2s already present, and then one COOH. So this is the first reaction, isn't it? Now you can see that this is your first reagent. Then you have dehydrating agent. Actually heating symbol should be mentioned, and when you carry out dehydration, that is removal of H2O over here, you know that you will be getting what? CH2 CH2 CH2, that is 3 HCH2s, isn't it? How many CH2s are present? Actually you need to check carefully before you mark your answer, isn't it? You have to get 1 2 3 4 5 and then 6 membered ring, isn't it? So what is that R which you are getting? You can see that your R is having, I'm writing your R here, alright. Has a C double bond over here, isn't it? 3 CH2, 1, 2 and then 3. So this is your R. Is that okay? So this is not your R. Alright. After that, you see what you're doing is that you're treating this with Grignard reagent, CH3 MgBr. You know that Grignard reagent will attack here to give you subsequently hydrolyzed product. What is that you're getting? Tertiary butyl methyls. You'll be getting what? A CH3 and a OH. Now this is after these two reagents attacking it. Now you can see you are using again dehydrating agent. That means you are removing H2O, right, from ZF positions. That means you will be getting a double bond over here. You have to check the option, isn't it? So that is nothing but S. So you can see that it is giving rise to S. You can see that you got a double bond here. So right answer for this question should be option B and option T. Okay. Chalo, let's see the next question. Most of the questions are sequential root map questions. You can see that treatment of benzene with CO and HCl in presence of aluminum chloride, right? Know that it is Gatterman Koch reaction if there is phenol, but a kind of Gatterman Koch reaction only. So what will happen initially? Benzene, these reactions are more prominent if there is electron withdrawing group present. So you got benzaldehyde. Alright, now you see after that, this is the reaction that is taking place, and then subsequently it is reacting with acetic anhydride, right? CH3, C double bond O, C double bond O, CH3. Now what you have to do is you have to remove H2O. This is nothing but Perkin condensation, isn't it? You have studied, right? Perkin condensation. So what is that you are going to get? Only aromatic aldehyde would react, and you have done the hydrolysis also, so this part also gets eliminated. So finally you will be getting cinnamic acid, right? So this is your X. Alright, now we can see that this compound X is treated with bromine in presence of protic solvent. Alright, so you got the addition of this. Alright, two bromines are being added. So when bromine is added, you will be getting, you have studied, isn't it? Cyclic brominium ion, isn't it? Now we can see you are treating or heating it with KOH. So when you are heating it with KOH or carbonate ion, it not only eliminates the carbon dioxide but also removes the HBr. So there is the elimination of carbon dioxide as well as HBr because you are using the combination of two strong bases. Alright, so you will be getting this option C as the product Y. Alright, now let's see that in the same reaction, yes, isn't it? In the same reaction, so you got product Y, isn't it? Now reaction of X with, yes, let me write the product also in the next question. You see, it's a continuation of the question. So this is your option C was your correct answer in the previous question. So this is your product Y. So this part is done. That means question number 15 is over. Now you can see your this substance X, isn't it? You've got X, and X is treated with hydrogen in presence of palladium charcoal. So you can see what you will be getting here when I treat it with H2 in presence of palladium charcoal. So you know that I will be getting double bond. This double bond gets reduced because of the reduction. Then you have got C double bond OH. Same reaction you have seen in the previous question also, dehydration. Now we can see we are treating this with H3PO4. So whenever you see H3PO4, you have to understand that you are removing H2O, the intramolecular dehydration, and you are writing a ring as well, right? So what is the size of the ring? 1, 2, 3, 4, and then 5-membered ring, right? With a C double bond adjoining, isn't it? So compound Z is your option A. So for 15th question, the right answer, this is Y, and this is your Z. Option A is the right answer to the question. Hope you understood. Alright, let's see another sequential reaction. You can see there is an organic acid P. See, whenever you find this carbon hydrogen ratio 1:1, you need to understand that it is derivative of benzene, because benzene molecular formula is C6H6. 1:1 is the ratio. And one more thing, that you need to find out the double bond index. or degree of unsaturation, that is 11 into 2, isn't it? 11 carbon atoms, 11 into 2, 22 plus 2 minus existing hydrogens are 12 by 2, that means 6. There is 6 degree of unsaturation, that means rings, pi bonds all put together. You can see that this can be easily oxidized to a dibasic acid which reacts with ethylene. You know that you have studied, isn't it, in polymers? So this is slightly combining with the polymers also. You can see that when I take a terephthalic acid and treat it with ethylene glycol, condensation will take place to give you what? Dacron, right? So what you have to do here, remove. It's a polyester, isn't it? So dacron is a polyester. So you will be getting what? O CH2 CH2 O CO C6H5, that is benzene, COO CH2 CH2 and so on. So this is what you call as dacron, right? So the formation of dacron indicates that the positioning of the substitution is 1, 4. So 1, 2 is ruled out. You can see option B as well as option D are ruled out because the dacron is formed by the terephthalic acid. Now you can see upon O's analysis, you have to get to the correct structure of the compound. You have got the degree of unsaturation as 6 and you found that the two substitutions are at 1, 4, isn't it? 1, 4 substitution, 1, 4 substitution. So I ruled out option B and D. Upon O's analysis, P gives aliphatic ketone as one of the products, isn't it? Aliphatic ketone, right? Now P gives rise to aliphatic ketone. So you need to write the compound structure in such a way that you will be getting aliphatic ketone. You can see that 6 degree of unsaturation must also be there. So you should not speculate the product, but rather you should be sure about it. So the point is you have a substitution at 1, 4 positions and there are 2 oxygens. I presume that it is COOH. Why I am writing COOH is because I need to have total 11 carbon atom. Already I covered 7 and I need to have a ketone, isn't it? So you see, I take 1 CH3 here because I have to get a ketone, aliphatic ketone. I need to have 3 minimum carbon atoms adjacent, right? So 4 degree of unsaturation is covered in the benzene, 3 pi bonds, 1 ring, 4, 5, and there should be 1 degree of unsaturation in the side chain. So that I am keeping it here, and also it should give rise to what? Aliphatic ketone. The minimum number of carbon required for the aliphatic ketone is nothing but 3. So I will presume that this is your compound P. Alright, you can see that when I am doing the O's analysis over here, I will be getting what? Acetone, right? CH3, C double bond, CH3. So this is scattering to my needs, and you have to write the sequence of the reaction. Now you can see that this P is being taken and treated with H2 in presence of palladium charcoal. So I am writing this left side sequence first. COOH. What do you have? CH2, CH, CH3, CH3. This is your first product. Then you have treated this with ammonia. You know that when treated with ammonia, this will convert into amide. Alright. So you need to solve such questions very carefully. CH2, CH, CH3, CH3, C double bond, NH2. And you know, when you have treated this with bromine and NaOH, Hoffman bromamide reaction, right? Bromine and OH minus will convert this whole thing into amine, right? So you have got CH2, CH, and this will convert into primary amine. This is how you will convert this amide into primary amine. Now you know that this is when treated with chloroform and KOH, very popular isocyanate reaction, isn't it? So what do you get? You will be getting a benzene, alright, with this substitution, and this whole thing will be converted into NC, isocyanate, right? Now you know isocyanates upon reduction by using hydrogen in presence of palladium charcoal, you know, isocyanates gives rise to what? Secondary amine. CH2, then NH, CS3. So this is your compound S. Alright, isn't it? Now we have got this P, which is subjected to sequence of reactions. Listen, right, getting complicated, isn't it? Now first reaction is same. In the second reaction, what you're doing, treating it with SOCl2. So I'll write this part like this. So it will become what? C double bond O Cl, because that got reduced, and then second step is also done. Then methyl magnesium bromide, that. Then when treated with methyl magnesium bromide, this whole thing will be converted into, I'm not writing this whole thing, C double bond O CS3. Then reduced by using sodium borohydrate. Not difficult, only the sequential reaction. All repeatedly known reagents are only covered, but you are writing it more number of times. So CHOH, CH3. So this is your Q. So you got Q, which is a 2-degree alcohol. Now you can see this Q is again subjected to the reaction with HCl. Oh my god. So what will happen? This is intact. It will become CH, Cl, then magnesium bromide. So I will be writing directly CH, CH3. You know that when treated with magnesium, it will give rise to what? MgCl. And you know what will happen when you treat this with carbon dioxide? This whole group will be converted into what? COOH, preparation of carboxylic acid using Grignard reagent. So you will be getting what? CH, COOH, and then CH3. So this is your R. So isn't it? So compound R is, let's check. You should have 1,4 substitution, CH, CH3, then what is this tail? CH2, CH, CH3, CH2. So option A is perfectly matching to the question, right? Beautiful question, isn't it? Next, I think next question also has a link. Yes, compound S is being asked. You can see this is compound S, alright, CH2, CH, CH3, CH3, and NaCH3. Yes, option B is the right answer for compound S. Alright, let's see the next question, which is match the following type. This is somewhat pinacol, pinacolone type of reaction. In that reaction, one has to be specific if it is unsymmetrical. You can see that if it is unsymmetrical, first of all, carbocation, the stable carbocation is formed. So what happens is this OH will go when you treat it with H2SO4. You will get a carbocation here because it is stable. Then you have methyl migrating here, and then hydrogen loss. So I am writing the product in a single step. So what's the product here? Methyl shifted, 2 phenyls are already there. C double bond O CH3. So this is the product out of your P. Now over here you just check, when I am treating with HNO2, you know that it will lose H2O, and N2 gives rise to initially the alcohol, and which will react with H plus to again lose this OH. Then migratory aptitude, you can see that clearly mentioned that hydrogen is least, so methyl will migrate here, and finally hydrogen will go. So what is that you are getting here? CH3 shifted, 2 pH already there, C double bond O H. This is the product out of Q. Over here you just see OH goes, methyl and phenyl, migratory aptitude of phenyl is greater, it is mentioned, aryl is greater, and finally to compensate the positive charge, this hydrogen will go. So what's the product here? pH has migrated, already one pH is there, CH3 is already there, C double bond O CH3. Over here you can see what's happening. When treated with AgNO3, Br goes, carbocation stable formed. After that methyl migratory aptitude is more, then hydrogen will be lost. So what's the final product? Methyl migrated, already 2 phenyls are there, isn't it? C double bond of H. Now we can notice one thing, that if I call this as product 1 and this as product 2, you can see this is a repetition of product 1 and this is a repetition of product 2, isn't it? The same product, no? Right? You can see these two are same and these two are also same, exactly same. So your option should match to that, right? So you can see clearly that when you take this product, I2NaOH is iodoform reagent and this is tolerance. This is anyways given as failing, alright. Then this is also bromoform. I'll just see what it is. Maybe it is crossed aldol condensation. Alright, now let's see the options. You can see P, that P giving rise to a product which is 1, is a ketone which has this group. So I2 and OH minus. So you can see P is matching with 1 and it also react with formaldehyde in presence of NaOH, that we will see later, but there is no such option matching. Alright, and you can see that 5 is matching because iodoform or bromoform, one and the same reaction. So P matching with what? 1 comma 5, bromoform reagent, iodoform reagent. So P is 1 comma 5. Let's see Q. Alright, so P is 1 comma 5 means R is also isn't it? What is this? The product over here is also. So P and R should be matching with each other, and you can see the product of Q should be matching with S, is equal to, you can see when you take the product of Q, it has an aldehyde group which will react with the tolerance as well as failing. So this is matching with 2 comma 3, isn't it? So P and R are matching 1 comma 5, Q and S are matching 2 comma 3. Right option is option D, Delhi. Interesting question. Let's see the matching type of question once again. You know that this is a strong base, bulky base. It will carry out the elimination because 3-degree alkyl halide is taken, and preferably with a strong base, 3-degree alkyl halide prefers an alkene. So what's the product of the reaction? CH3, C double bond CH2, CH3 plus tertiary butyl alcohol, COH. This has abstracted a proton from here, right? So tertiary butyl alcohol, you can see that P is matching with 1, and also you can see that this product is also CH3, CH3 double bond CH2. So 1 comma 4, isn't it? So P is matching with 1 comma 4. So I'll rule out option A and D. I'll stick to B and C then. Now you can see this is a simple, right? NHBr attacks, so you'll be getting a carbocation which is 3-degree stable. So you'll be getting what? CH3 taken thrice CBr plus methyl alcohol. So you can see Q is matching with tertiary butyl alcohol, that is 1. Carefully we have to solve this question. No, tertiary butyl alcohol, no. This is, you can see it is becoming tertiary 2, no, isn't it? It is becoming 2. Tertiary butyl bromide is the product. Q is matching with 2, isn't it? Q is matching with 2. We will see the remaining options. You can see that this is again 3-degree alkyl halide and this is a strong base, so give rise to a dehydrohalogenation product, that is nothing but once again 4. So R is matching with 4, dehydrohalogenation, same like 1. 3-degree undergoes dehydrohalogenation. Now this undergoes the Williamson ether synthesis because this is methyl bromide, follows SN2 mechanism, giving rise to option 3. So you can see that S is matching with option 3. So P is 1 comma 4, Q is 2, R is 4, S is 3. So right option for this question is option B, isn't it? Now let's see the next question. For the synthesis of benzoic acid, there is a set of compounds, reagents, and type of reaction is given in 3 columns. You have to match it with each other. This is the beauty of JEE Advanced. They will match the reaction with the concept also, or type of reaction also. You have to carefully solve the question, right? Let's see. You want to prepare what? Benzoic acid out of this 4 options given. So this is your interest. Check out the option 3, 4, R. 3 is benzaldehyde, 4 is NaOH plus CO2. Benzaldehyde doesn't react. Actually, it would have been a reaction of what you call the Schmidt reaction, where you will be getting COOH at ortho to phenol, isn't it? You want benzoic acid, so this is ruled out. 4, 2P. 4 is phenol, 2 is bromination, doesn't make any sense. 4 then 2 not matching because it has no significance. 1 is toluene, 4 is NaOH and CO2, same is the issue. Let's see the last option, that is 2 acetophenone you have got, isn't it? You got 2 is what? Acetophenone, C double bond O, CH3. 1 is NaOH and Br2, that is bromoform reaction, where this group will be converted into CHBr3. So we are eliminating CHBr3 and you got the remaining group as COOH. So 1, 2 and S, because it is haloform reaction. So perfect answer should be option D. The only correct combination in which the reaction proceeds through a radical mechanism. Free radical is only 2. So you have to pick where 2 is present. You can see it is present in option C and A, and you have to write the reaction accordingly. 1, 2 and R makes sense. 3, 2P, because when you take toluene, when you carry out bromination, the product is benzyl bromide, and this reaction takes place at the benzylic position because this radical is benzylic radical and it is stable, isn't it? So 2, 2 and P, acetophenone, no, this is not possible. Then you see the correct combination that gives 2 different carboxylic acids. 4, 3Q, 4 is phenol. Let's see, you have phenol. 3 is a Perkin reagent, so 4, 3 and Q, carboxylation, okay. AC2O acylation gives rise to what? OCO CH3. This is Schotten-Baumann reaction, where carboxylic acid is not prepared, isn't it? Q, carboxylation should take place, no? Next, let's see the next option. 3, 3P. Benzaldehyde, yes, this seems to be a bit okay. Benzaldehyde in presence of AC2O. Perkin condensation, we have just seen this reaction in the previous question, isn't it? You will get cinnamic acid, CH double bond CH, COOH. So 3 and then condensation, yes, Perkin condensation. So 3, 3P looks to be okay. Option A is ruled out. 2, 4R. 2 is acetophenone, 4 is NaOH, 2 is acetophenone and NaOH CO2. I don't think so this reaction takes place because that occurs on simple benzene or the substituted electron releasing group substituted, but not electron withdrawing group substituted. Only one option, anyways we got the right answer, but we must check the remaining options also. Option D is 1, 1S. 1, 1 toluene and NaOH Br2 doesn't make any sense, right? So right option for this question should be option B. Alright, so that's all for today. Keep watching. That's it.